All right, chemistry class. We are still in chapter 7 here, and I believe I mentioned that for this chapter I was going to walk through these review questions with you. Now I do provide you the answers to check, but I think it's good to talk about these questions in this chapter, okay? All right, I may go through some of them, not all of them, just give you plenty of examples, and then you can do the rest. Number one, monatomic ion. You can go back in the chapter and look at this, but basically it is an ion, a charged particle with just one atom. So like potassium ion. Potassium's in group 1, so it has a +1 ion. Or we could have negative ions like chloride ion. Or it could be, these just have to be one atom now. These are not polyatomic. It could be a metal like iron. Iron, remember, could have a multiple ions possibilities, something like that. Okay? It says using only the periodic table, write the symbol of the ion most typically formed by each of the following elements. So let's look at a periodic table. And if you remember, everything in group 1 has one valence electron. So it's going to want to get rid of that valence electron and therefore form an ion of a +1 charge. It's getting rid of a negative ion, or negative electron. Everything in group 2 has two valence electrons. Those metals want to get rid of those two valence electrons, so they're going to form a 2+ ion. We're going to skip over the transition elements because there's variations there. In group 13, they have three valence electrons, and they want to get rid of those, and so if they do, it's going to form a 3+ ion. The carbon group here, group 14, mostly likes to share. That's 4 valence electrons. They're going to get rid of 4 or gain 4. It's more likely to share. Nitrogen group here, this group, group 15, has 5 valence electrons. Is it going to get rid of 5 or is it going to gain 3 to get the octet? It's more likely to gain 3, and so it's going to have a 3 negative charge for these ions. Oxygen has, group 16 has 6 valence electrons. Is it going to get rid of 6 or just gain 2? It's going to just gain 2. Non-metals over here like to gain electrons. Metals like to lose electrons. Fluorine and the rest of these, group 17, have 7 valence electrons. They're just going to gain 1 and have a -1 charge on their ions. And the noble gases are stable. They don't like to gain or lose. So going back to our question here, it says potassium. All we have to do is just check and see what group it's in. Potassium is in group 1, so it's likely to lose that valence electron and have a +1 ion charge on it. Sulfur. Sulfur, what group is that in? Sulfur is right here in the oxygen group. 6 valence electrons, it's likely to gain 2 more to get the octet. So it's going to gain 2 and have a 2 negative charge. Calcium is in group 2. That metal is likely to lose its 2 valence electrons. Okay? This says write the formula for and indicate the charge on each of the following ions. Now these are just the same as up here, the same as number 2, but they just give us the name. So sodium ion. Sodium is in group 1, +1. Aluminum is in group 13, so it's likely to lose those 3 valence electrons. Chloride, notice the ending here with a non-metal ion, the ending there, IDE. Chloride is in group 17, it's likely to gain 1. Nitride, that's nitrogen. Nitrogen is in group 15, so it's likely to gain 3 more to get its 8. Iron 2, this is nice, they're just telling us. Remember, iron can have multiple ions, so actually when we use the Roman numerals, they're telling us exactly what the charge is going to be on this. And that's how easy it is. Okay? Now it says, write formulas for the binary two elements coming together, and it's ionic, so it should be a metal and a non-metal, and we're going to write the formulas for these. Now remember, the way that they come together is the ions have to come together in a ratio to form a neutral compound. Okay? So I'm going to show you the ions and then show you what ratio they come together. In what ratio. Sodium and iodine. So sodium is going to form a +1 ion because it's in group 1. Iodine is in group 17. It's going to form a -1. Sodium gives its electron to iodine. It forms an iodide ion, and we have a sodium ion. They're going to come together in a 1-to-1 ratio to form a neutral compound. Barium and fluorine. Barium is in group 2, so it's going to give up 2 electrons to fluorine, but fluorine only needs 1. So to give up 2 electrons to fluorine, it's going to need 2 fluorines. So remember what we do here? To come up with the formula, if this charge here is a 2, then I'm going to need 2 of the fluoride ions, or 2 of the fluorine atoms in that compound. The fluoride ion is a -1, so I just need 1 of the barium. You never write 1 for the subscript, and that's your formula. Calcium and sulfur. Calcium is in group 2. It forms a 2+ ion. Sulfur is in group, same as oxygen, right? I think so. Yep. So that's group 16, forms a -2 ion. You just need 1 of each. +2, -2, just 1 of each. This is just going to be CaS. Lithium and oxygen. Lithium is going to form a +1 ion. It's in group 1. Oxygen, 2 negative, is in group 16. When they come together, I'm going to need 2 lithiums to neutralize the 1 oxygen to make a total neutral atom here. So 2 and 1. Okay? All right, let's name these. I should be able to ask you to do either one. Give the formula or give me the name. This is potassium chloride. Notice the ending change. You don't need the prefixes here. Do not use prefixes for ionic compounds, metal and nonmetal. It doesn't matter. We don't need prefixes because we already know how many of each based upon the ion charges and the ratio that they must come together in to make a neutral compound. This is calcium bromide. Just the nonmetal changes its ending. This is lithium oxide. This is magnesium chloride. Okay? Okay, now we're going to get into molecular compounds. And you see, anytime you see molecular compounds, it is covalent. Covalent. Now, this is not ionic. And when atoms, nonmetals, when they share electrons, they can share them in multiple ways. So, for example, carbon and oxygen, they might share in a way where you just need 1 carbon and 1 oxygen. Or, that's carbon monoxide. Or, they might share in such a way where carbon needs to be bonded with 2 oxygens. That's carbon dioxide. So we can't just say carbon oxide, because carbon and oxygen can form in multiple ways. This is where we use prefixes. You have to use prefixes when it says molecular or covalent. And these are binary, just 2, and the prefixes tell us exactly how many. Carbon, C, tetra means 4, bromide is from bromine, so that is Br4. Done. Silicon, Si. Di is 2, oxide is oxygen, O2. Tetra, phosphorus, so P4. Dec oxide, deca, remember deca is 10, oxide, oxygen. Di-arsenic, so Ar2, arsenic, there's 2 of them, di. Trisulfide, so sulfur, sulfide is from sulfur, that's a sulfur, a nonmetal, and tri is 3. And it's just that easy. Okay? Alright, acids, I told you we're not going to worry about acids. Now, let's go back to ions. We're going to go back to ions, and we're going to work with metals that have multiple charges. Remember, there is a system where we just use Roman numerals. These are ions now, and all you do is you just look at the charge. This is iron 2 with Roman numerals. This is iron 3. Okay, I'm not going to do the rest because this is lead 2, lead 4. The Roman numeral 4 is an I or a V there. And then this is tin 2 and tin 4. Just that easy. Okay? We'll jump here and do some more examples of these. It says write formulas for each of the following compounds. So now we're going to have, in this case, these are all ionic. I know because it's a metal and a nonmetal. Metal, nonmetal, metal, nonmetal. We're going to write the formulas this time. These are all ionic. Sodium fluoride. Sodium forms a +1 ion. Fluoride is a -1. I just need one of each. Calcium is a +2. Oxygen is a -2. One of each to make a neutral compound. Potassium is a +1. Sulfur, sulfide there, is a -2. So I'm going to need 2 potassium for the 1 sulfide ion. Iron 2 oxide. Well, iron 2 is a +2. Oxygen is a -2. So I just need one of each. Aluminum is a +3. Bromide is a -1. So I'm going to need 3, bromide, Br. 3 Brs to match the 1 aluminum. Okay? Lithium is a +1. Nitrogen is a -3. So I'm going to need 3 lithiums to counteract the 1 nitride ion. Okay? Now this time we're going to use the stock system because we might have multiple. See the iron here? That's got multiple. This mercury might have multiple. Okay? If it doesn't, then we don't have to use Roman numerals. Sodium is always a +1. Chloride is always a -1. So this is just sodium chloride. I don't need Roman numerals because those ions are fixed. They never change. This is potassium fluoride. And this is calcium sulfide. Those ions are never changing for those. But over here, iron could be a +2 or a +3. Don't know. Well, all we do is we look at this here. No, you have to recognize that that is a group. That's a polyatomic ion. That is PO4. That's phosphate. And you look in the table, okay, you would look back in the table of polyatomic ions and you would realize that phosphate is a 3 negative charge. And I've got one of this group along with 1 iron. So that iron must be a +3. So this must be iron 3 phosphate. Okay? Here's another group. There's a sulfate. And I know that sulfate is a -2 charge. Just look back at the chart. So if a sulfate is a -2 charge, that polyatomic ion, and it looks like I need 2 mercuries here, then it must be mercury 1. Mercury 1 sulfate. Here, there's our phosphate again, and look, I need 2 of them for every 3 mercuries. So if this is phosphate, phosphate charge never changes. It's always -3. That phosphate is a -3, and look, we got 3 mercuries, 2 phosphate, so this must be mercury 2. 2 is the charge on mercury. Phosphate's charge is -3, so that's why I need 3 mercuries and 2 phosphates to make a neutral atom. Okay? Alright, we did not talk about oxidation numbers. We'll come back to that in a later chapter. Alright, let's work through a couple of these. And I'm going to do a couple of them, and then you're going to work on some others. I'll do A, and then you can do B. It says find the formula mass. All you do is you look on the periodic table. That's all you have to do. In this formula right here, this is sugar, glucose. We have 6 carbons. So I'm going to take 6 times its mass. So I just look on the periodic table. Carbon, oh, I don't have it here. Alright, this periodic table is not showing the masses. So I'm going to let you do the calculation. Alright, you're going to open up a periodic table that has the masses on there. And you take 6 times the mass of carbon, which is around 12. Okay? I take 12 times the mass of hydrogen from the periodic table. So 12 times, it's about 1, just rounding off. I have 6 oxygens. Oxygen is about 16. And I'm going to multiply all those. This is 72, 12, and 96, and I just add all of those together. So whatever that is, that sum there, I think I can do this, 180, that's 180. Now if this is the formula mass, this is 180 AMUs, or sometimes they just use a U, that would be the mass of this compound in AMUs. If we were looking for the molar mass would be exactly the same number. All of these would be the same numbers over here, except it would be in grams. How convenient is that? Okay, you can do B. 14 here says determine the number of moles of each ion in 1 mole of the following compound. So you have 1 mole. I'm going to put a big 1 here to denote we have 1 mole of this calcium phosphate. Well, inside of there are ions or atoms. How many of each do we have? If we have 1 mole of this whole compound, how many of the individual atoms or ions do we have? Well, inside there we have 3 calcium for every 1 compound. So there's going to be 3 moles of calcium. And inside here we've got P, phosphorus, in this group, but look, it's doubled. So there's 2 moles of the phosphorus. And there's 4 oxygen in this group, but then it's doubled. So there's 8 moles of the oxygen. Okay? And I'm sure you can do this one. Alright, let me walk you through this one. The numbers, you can figure out the numbers. You can look on the periodic table and find the numbers. I'll just walk you through it. This time we're finding the molar mass. So this is for 1 mole of this compound, and the unit is going to be in grams. But the numbers come straight from the periodic table. So all you do is you find on the periodic table the molar mass of aluminum. And you take 2 times that molar mass for aluminum. Then we look for chromium. Notice this whole group is tripled. So there are 3 chromium, so 3 times the molar mass for chromium. This was for aluminum. This is for chromium. And we have to take 3 times 4 for oxygen. So that's 12. 12 times the molar mass for oxygen. And you find out each of those numbers, and then you add them all together to get your answer. Okay? Okay, now, here we are going to convert from mass to moles. Or we could go back the other way, moles to mass. And in order to do that, we need the molar mass to do all that. Okay? So it says determine the number of moles in 4.50 grams of water. So what you do first is we got to find this molar mass. That's our bridge between mass and moles to go either direction. So the molar mass of water, in this formula, you got 2 hydrogens. Molar mass of hydrogen is 1, so 2 times 1 is 2, and 1 oxygen. Molar mass of oxygen is about 16. So your molar mass of water is 18 grams per mole. Every mole is 18 grams. Well, we don't have 18 grams. So obviously we don't even have 1 mole. How many do we have? Well, you just take 4.5 grams. This is for water, and you are going to divide by 18 grams. How do I know 18? Because 1 mole of water has a mass of 18 grams. I know to divide so I can cancel the grams. So 4.50 divided by 18, you can do that calculation and tell me then how many moles I have. We are in moles. Okay? Alright, let's do this one right here, 17. We're going to find the percent composition. Now, percent composition means of the total mass here, how much of that total mass is from the magnesium, is from the oxygen, is from the hydrogen. Okay? So what we do is we look on the periodic table, and you're going to look at the masses on the periodic table for each of these elements. And we're going to add them all up. So for magnesium, it's around 24, 24.3. We'll just use 24. I'm going to just round off right now. So there's just 1 magnesium in this compound, so 1 times 24. Oxygen, there are 2 of them. See this OH group? But it's doubled. So there are 2 oxygens, so that's 2 times 16. 16 is the molar mass of oxygen. And then there are 2 hydrogens. 2 times 1. 1 is the molar mass of hydrogen. So I've got 24, 2 times 16 is 32, 2 times 1 is 2. I'm going to add all of those up, and I'm going to get 58 grams, and that is per mole of this compound. Okay, that's the total molar mass. Or if you want to say formula mass, it would be 58 AMUs, okay, per compound, for one compound, for one of those units there. Now, I want the percent composition. So that means of this 58, how much is magnesium? Well, I'm just going to take these individual numbers for each of the elements and divide them by 58. So the percent for magnesium is going to be 24 divided by 58, and then multiply by 100 to get a percent, and you can do that. For percent for oxygen, it's just going to be 32 divided by 58 times 100. You can do that. And the percent for hydrogen is going to be 2 divided by 58 times 100, and you can do that. Okay, that's percent composition. I'll let you do 18. Notice it's asking for the percent by mass of water. So you'd find the total mass of all of this, and then find the mass of just the 5 moles of water, and take the mass of the water divided by the total. Okay? Okay, here at number 19, we're going the opposite direction. You are given the percentage, and we're going to find the formula. Now remember, the trick here was assume you have 100 grams to start. Okay? So if you have 100 grams to start, now the masses of each of these individual elements is easy, because 52.11% of 100 is 52.11. So we've got 52.11 grams of carbon, we've got 13.14 grams of hydrogen, and we've got 34.75 grams of oxygen. Now, that's the mass. I want to find out how many moles. Okay? When I write a formula for carbon, hydrogen, and oxygen, these subscripts are atoms, but they can also be moles if I have a mole of this compound. So I have to find out what I have here. I got to take each of these and divide by their molar mass. So for carbon, I take 52.11 and I divide by 12, which is the molar mass of carbon. For hydrogen, I take 13.14 and I divide by 1. For oxygen, I take 34.75 and I divide by 16. So do that on your calculator. Let's see what we get. Obviously, this is going to be around 13. This is going to be 34 divided by 16. That's around 2 point something. And 52 divided by 12, that's around 4 point something. Okay, so 4 times 12 is 48, right? So this is close to 4. Now, if these were not close to whole numbers, then you'd have to divide everything by the smallest of these numbers to get whole numbers. But they're pretty close to whole numbers here. Okay, so it looks like my formula is going to be C4H13O2. Okay? Okay, let's look at these two. Number 20 says, what is the molecular formula for a molecule that has an empirical formula of CH2O and a molar mass of 120? Okay, now here's the deal. Empirical formula, remember, is the smallest ratio. So this may be the molecular formula, or it may be multiples of that. Here's what I mean. Here's the empirical formula, CH2O. But the actual formula could be C2H4O2. That's a 1 to 2 ratio. This is a 1 to 2 ratio. It could be C3H6O3. Okay? It could be C4, H8O4. That's a 1 to 2 to 1 ratio as well. It has to stay in a 1 to 2 to 1 ratio. It has to stay in the same ratio. But if you look, this mass right here, carbon is 12, 2 hydrogens, that's 2, oxygen is 16. 2 or 12, 2, and 16, that's not going to give me 120. So this is only going to give me what? 28, 30. Okay, this is 30. This one is 30. I'm looking for which one has a mass of 120. Well, obviously, 120 divided by 30 is 4. I need the one that is 4 times this one, the original one. So 1, 2, okay, 1, 2, 3, 4. I need to multiply it by 4. So 1, 2, 3, 4. I need 4 times as many in order to get to what I'm looking for. Okay? So notice what I did here. I took the empirical formula and I found its mass, and then I took the actual mass of my molecule and I divided those to find out how many more. What is my multiplier? I need to multiply this original one by 4, so this is the formula that I'm looking for. Okay? C4H8O4. Okay, and the last one here is a compound with a formula mass of 42.08 is 85.64 carbon and 14.36 hydrogen. Find its molecular formula. Okay, so we are given the mass here. We have carbon and hydrogen. So we know our formula is going to have carbon and hydrogen in it. We are just trying to find out these subscripts there. Okay, the formula. We're given the total mass, and we're given the percentages of carbon and hydrogen there. So what we're going to do here, we want to look at the comparison between the percentages and the formula mass. All right. If 85.64% of this is carbon and 14.36% of it is hydrogen by mass, remember we said assume 100 grams sometimes, so that might be helpful here. But we are given the mass here, so we don't have to really assume that there's 100 grams because we're given the mass. What we're going to do is we're going to take these percentages, so 85.64% of 42.08. You're going to take, this is a decimal, this would be 0.8564, right? Multiply by 42.08. That's going to give you the mass of carbon. Mass of carbon in this compound. Here's the total mass, but only 85.64% of that is carbon. Then you're going to do the same thing for hydrogen. Take 14.36% and multiply by the total mass of 42. Then you'll have the mass of your hydrogen. Okay? Now what you want to do, if this is the mass of the carbon, and this is the mass of the hydrogen, you're now going to divide by their molar masses. Divide by 12 for carbon, divide by 1 for hydrogen. And that should give you these subscripts there. If it doesn't, then you have to divide by the smaller of the two to find out some whole number ratios there. Okay? Alright, please check those over. Let me know if you have questions. It'd be great if you could have these done and ready when you come to live sessions so we can answer any of your questions. Okay? As always, let me know what questions you have. I'm here to help. Just shoot me an email and we'll go over anything that you want. Alright, keep up the good work.